So this was just asking at a given temperature, the reaction A to B, and they have these arrows because it's reversible, has a constant of first order, so it's in direction of the first order, which just means that if you're going to write down the formula, which we'll do later, it's going to be to the power of 1. Okay, but the point being is that this first order reaction is, so the K forward is 2.9. Actually, I don't want to scroll over because that makes things annoying. Just gonna write under it. Equals 2.90 times 10 to the negative 2. And now, and that's just the units, seconds to the negative 1. That's what the units specifically for first order reaction. Now the reverse reaction is also first order, so the reverse reaction of this, okay, is going to now be, so K reverse is equal to 5.00 times 10 to the negative 2, same units. Okay, now a forward reaction, okay, this is where it gets really strange, because you want the equilibrium constant. All right, so K forward, okay, is equal to products over reactants. All right, so that's what we have there, products of reactants, and then KR, the reverse, is equal to, you know, reactants over products. Okay, and we want a value of the equilibrium constant, so aka when KF, okay, when the rate of one side, well actually you can have just K, and we want it when, you know, I guess KF, forward and reverse reaction are happening, I guess, at the same time to form that equilibrium. So what you want to do then is you want to actually put KF over KR for that, for the reaction A to B. You want the forward over the reverse reaction. Okay, and as we discussed, the forward reaction is that number here, the 2.90, and the reverse reaction is 5.00. Since they're both 10 to the negative 2, we don't really need that, but pretty much our K equilibrium constant from A to B is equal to just 0.580. That's what we get. And now we kind of just follow the same thing for now for the reversal, because now it's just going to be KR over KF, and it's just going to be 5.00 over 2.90. So that means this equilibrium constant, KBA, is equal to 1.72. Now, with these type of questions, the thing you have to remember is that when they're giving you the rate constants, that's what you want to be able to use to find the equilibrium constant. So they're giving you both directions, and what you have to do is pretty much just manipulate the equation for when you're trying to find the equilibrium constant for A to B, aka the forward one. You want to put the forward rate at the top and the reverse rate in the denominator. When they now go backwards, B to A, you want to make sure that you put the reverse rate in the numerator and the forward rate in the denominator. Okay, so that is how you would solve this question. And you notice it doesn't really have any units because of the fact that it's just two rate constants divided by each other. So let's see what we get here. So K equilibrium for the first one is 0.580, and then for the second one is 1.72. Perfect. Now we just kind of kept our significant additions, hence why I went this far. I did do the calculations beforehand, but exactly, see, here's what they did. Exactly, they have that the K forward. So just as a breakdown, just to make sure I'm doing this right. Okay, so this is actually a different part, so we can actually put this to the side. That's where we want to find concentrations. But in terms of when you have the so that's a different K, which is a little bit frustrating. So in fact, for your sake, I'm going to erase that, because the equation you're actually talking about is a rate of, you know, the equation is equal to, you use the constant that they gave you, the K forward, and then A, okay, to the power of 1, because this, remember, it's for first order, and that's the forward one, okay, and the rate reverse is KR B, okay, 1, and that's now how we go to this part. Okay, so what we're really doing is the full, I guess, equilibrium constant. In this case, now we're back to actually look for concentrations. Well, not really, but more so like the constant. A lot of different K's, you have to just watch out for that. It's pretty much going to be, depending on what we're solving for, the RF over R, okay, and then yeah, that's how we then break it down to this one, and then we solve the equation. So that is what we do for that question. If you have any more questions, just exactly, we always have more tutors, and we always want to help. So this is correct. Okay, and now question 7.